Okay, so for this one here, one of the things you could notice, this is there's three terms. First of all, three terms. Is it a trinomial? Well, this is pretty. It's pretty difficult to see like x squared plus whatever, like a trinomial to factor with two binomials. But what we could do is we could try to tear down or break up these secants and cosecants and all that. We could try and figure out if they combine in any way to make a tangent or a cotangent or something. So I might use that tip to change everything into sine and cos, or you could factor out a cosecant, I guess, because you'd have a cosecant squared. So you could factor, or you could break everything down to sine and cos. What do you want to do? You guys that asked about this. Break it down? Like, okay, so secant is what? 1 over cos? Cosecant is 1 over sine. Okay, I don't know if that's going to help us too much, but we'll give it a go. This cosecant, 1 over sine, times 1 over cos, plus 1. All over secant is 1 over cos. Okay, well, that might help us a little bit in that we can flip and multiply this, right? So this is just times cos now, and if we do that, we are going to get rid of some of the coses over here, so that might actually work pretty good. So we're going to flip and multiplying by cos. So this cos is gone with this for this term. This cos is gone for this term, and we have this turns into just a cos. So I have 1 over sine cubed theta. That's what I have left over here. I have 1 over sine theta, and I have cos theta. Okay. So I look over to the right, and I do have plus cos theta all by itself, so that's kind of nice. I might just want to try and focus on this and see what I can do here. Maybe I should try and combine these into one term. So let's multiply this one over here, get a common denominator. Let's do sine squared theta top and bottom. So I'm going to combine these two. So that's going to be 1 minus sine squared theta on top, and on the bottom I'm going to have sine cubed theta. All right. 1 minus sine squared, right? Okay, 1 minus sine squared. Okay, so what is 1? Oh, and we got plus cos, so forget about that. What's 1 minus sine squared theta? Yeah, that's cos squared theta over sine cubed theta plus cos theta. And now, if I have cos over sine, I can now start to split this up and have a cotangent, which I do need a cotangent over here, right? So I would split it up like this, cos squared theta over sine squared theta times 1 over sine theta. See, so this right here becomes this. And I do that because cos over sine is cotangent, and cos squared over sine squared is cotan squared. And 1 over sine is cosecant. So I have cotan squared theta from here, and I have cosecant theta from here, plus cos theta, and I believe that is what we were going for. Let's see. Yeah, cosecant theta times cotan squared theta plus cos theta. So we are done.
I think we just are all over collectively over.
Now there is the other method, is the factor method, which may be a little bit easier. I'm not sure. I could do that one too, where you factor a secant and a cosecant out. So I would be, do you want me to do that one too? Because some of you might just say, hey, I want to factor here, which would totally be fine too. So maybe I'll try and do that over on the right here, if I can. So here's method 2. I could take out a secant and a cosecant out of these first two terms. And I have secant theta, cosecant theta. And what do I have left? I have cosecant squared theta minus 1. And that actually looks pretty good, doesn't it? What's cosecant squared theta minus 1? And we might need to go back to our identities there, right? Cosecant squared theta minus 1, where is it? Oh, there's cosecant squared theta minus 1. That's cotan squared. You see from right here? Oops. Okay, that's not going to help. But anyways, so cosecant squared minus 1 is cotan squared. So this right here is cotan squared. So I have secant theta, cosecant theta times cotan squared theta plus 1 all over secant theta. And from here, you can take this as a fraction separately from this. So you can write this as two fractions. So that's going to look like secant theta cosecant theta cotan squared theta over secant theta plus 1 over secant theta. And we are very close to being done here, actually, because secant theta goes with secant theta there. And I have what I'm looking for. I have cosecant theta cotan squared theta plus, and 1 over secant is 1 over secant is cosine. So that is option number 2. Okay, yeah, that's getting to be tricky for sure. But write everything in terms of sine and cos, and multiply, divide out common factors, or you can factor that, use your identities, separate your fractions, simplify. Those would be the two methods for 22. Does that help, or is that generating more questions? Not sure.